All right, this video is a continuation of the limiting and excess video. I did it in a discussion in 3 new terms that kind of play right into stoichiometry. And those 3 terms are theoretical yield, actual yield, and percent yield. So theoretical yield, actually, we have been calculating this whole time. We have just not used that term. I have not used that term with you. So the theoretical yield is defined as the on-paper stoich calculated amount of product that a reaction can produce. So this is pretty much like, and I'll do a very generic reaction here, but like when we have, A plus B making C, and your problem says, okay, I have so much A and I have so much B, how much C, how many grams of C can you make? Well, that is the theoretical yield of C. Okay, so you've actually been calculating that this whole time. We just didn't call it the theoretical yield, but now we will. So theoretical yield, you do your sequences and you figure out how much product you can make. Okay. The actual yield is exactly what it sounds like. It's the amount that you would actually create if you did this reaction in a lab. Okay, so amount of product actually created from a reaction in the lab setting. Okay. So physically doing the lab, well, what could I truly create in the lab, actual yield, versus on paper, what does the stoichiometry tell me that I should be able to create? Okay, my example in class was, a silly example, but talking about like a recipe. Again, we always equate this to a recipe. So let's say you're baking cookies and your cookie recipe says you should be able to make, this recipe yields 24 cookies. Well, there could be numerous reasons why maybe you don't get 24 cookies, right? Like maybe you made cookies that were a little larger and so you only got 20 cookies, or maybe somebody ate some of the cookie dough, right? And you didn't get as many cookies. Maybe you dropped some cookie dough on the floor, right? There's all kinds of reasons why in baking, you don't get what you think you're going to get. And there's also some reasons in chemistry too, which we'll talk about later. So even though on paper we say, hey, I think I should be able to get this much C, theoretical yield, and then we do the reaction and we say, hey, guess what? Actually, I only got this much. There are several reasons for that. Okay, so hopefully you can see the difference between actual and theoretical yield. Those 2 quantities together allow us to calculate something called the percent yield. And the percent yield is a formula which says if we take the actual, divide it by the theoretical, and multiply by 100, we can calculate this quantity called percent yield. One thing to note, actual and theoretical yields can be in either unit of grams or moles, but you have to be consistent. So what I mean by that, of course, is if you're going to calculate a percent yield and you have a theoretical yield in grams, then your actual yield is going to come out in grams, right? So like whatever this is, this has to be moles and moles, grams and grams, whatever, but they have to be consistent, okay? And we'll see that in this practice problem. Okay, so those are the 3 new ideas in Stoich, and it's just now how do they relate to a problem, and what's it going to look like for us when we see those terms in a problem. Okay, so we have an example, and I goofed because I'm missing some numbers, so I didn't give you any data, so I have to put some numbers in this problem for you. All right, so we're going to edit this just a little bit. All right, so it says aqueous solutions of iron 3 bromide and potassium carbonate undergo a reaction. Well, I need to know how much. So let's say I have 255 grams of the iron 3 bromide and 185 grams of the potassium carbonate. So, whoops, I left that out. All right, and here are my 2 questions. A, what's the theoretical yield of the precipitate? And then B, if the percent yield of this reaction is 84%, how many grams of the precipitate can you expect to make in the lab? Okay, so step 1, of course, and I'll go quickly through this. So if you want to try this on your own, of course, you could always pause this video. I highly recommend that you do that. Or if you're not sure where to start, you can just listen to my explanation. Okay, so I need to write my reaction. So iron 3 bromide and potassium carbonate. Double replacement reaction, we create KBr. And let's see, it was iron 3 bromide, so Fe2CO3, 3. This cannot be the precipitate because it's got a group 1, so it must be aqueous, which means the iron 3 carbonate has to be the precipitate. Before we go any further, of course, we need to balance. So let's see. Carbonates, I'm going to need 3. Gives me 6 potassiums, 6 bromines, so 2, and this is a 1. Okay. All right, from here, we're proceeding like normal. It's a stoich problem, and not only is it stoich, it's a limiting problem because I have information on both reactants, and I'm being asked, what's the theoretical yield of the precipitate, right? Prior to today, that question would have been asked, how many grams of the precipitate can be made, right? Or how many moles or whatever. All right, so grams to moles, and I need to write my sequences. 255. Again, this is where you really want to be careful that you don't make a mathematical error because your molar masses dictate your sequences, and then it will all go awry. So, again, I highly recommend that at this point you pause this, you do your calculations, you write your sequences, and then you can resume the video because I'm just going to throw the numbers in there pretty quickly since this is just a recording for you. Okay, so let's see. I have a molar mass of iron 3 bromide. Actually, I don't have this. I need to get a calculator. Oh boy, I thought I was looking at it. Okay, so let's see. Iron 79. Okay, so molar mass is 295.55. And that comes out, again, 3 sig figs in my final answer, so let's carry a 4th. And molar mass of potassium carbonate is 138.21. Crunch that. 4 sig figs, 1.339. Right to my sequences to fill these out. Oops, 1.142. Okay. And this is the point where I have to decide which sequence is invalid. And so that would be, of course, the bottom sequence. All right. And so here comes our new word. The question asked me, what's the theoretical yield of the precipitate? They don't give me a unit. So I could report this answer in moles, or I could report this answer in grams. It really doesn't matter. But here it is, right? That is the theoretical yield in moles of the precipitate. Since they didn't specify, I'm just going to leave it in moles because that's a perfectly acceptable answer. Okay. Now, again, if they had said, what's the theoretical yield in grams, I would have to go one step further for that, but it didn't say. So we'll just leave it as moles. Okay. So that's the old stuff, though. You've done this the whole time. Again, the only new part here was the word of theoretical, but the math was the same. Okay. Now, part B involves new math. Okay, which says if your percent yield is 84%, how many grams of the precipitate can you expect to make in the lab? So this is a percent yield problem, which is actual over theoretical. They gave us the percent yield, which was 84. And they're asking me to find actual. And I know that because I just calculated the theoretical yield, okay? So this is just an algebra problem. What's my number? 3807 moles. And they're just asking me to find actual, okay? So rearrange this thing algebraically, solve for A, divide both sides by 100. That gives me 0.84 equal to A over 0.3807, and then multiply both sides by your moles. We end up with A, actual, right, yield, being equal to 0.3198 moles. Okay, and again, you might think you're done. However, this time they were specific, and they said how many grams of the precipitate. So that's the moles of the precipitate, if that's my actual, but I need to do a molar mass to gram conversion. So my precipitate is this, right? Quite the large molar mass here. 2 irons, 3 carbons, 9 oxygens. The molar mass is large, comes out to be 291.73. And then this is going to be my final answer, so I'm going to sig fig it all the way back to 3 sig figs because that's what I was given in the problem. And my actual yield in grams for my precipitate comes out to be 93.3, which is according to this reaction and the percent yield given, what you would actually produce in the lab if you ran this reaction. Okay. So that's the difference between theoretical, the on paper number, and actual yield. Well, what would I really make if I did this reaction in the lab?